Morning, everyone. My name is Chris Fantine, Chief Technologist for the West Coast at Red Hat in North America. And today I'm going to talk about continuous security with Kubernetes from a developer as well as operations perspective. But first, talk about some of the industry drivers. Certainly there's a lot of pressure on security and the need to move faster. Security is often seen as a bottleneck. And here's an example of the Tesla automobile factory, and software is certainly enabling the rapid production of these vehicles, but also for the first time, a vehicle can receive over-the-wire updates to provide new functionality, security updates, and it's really a necessity to enable new business ideas such as autonomous driving, right? Simply could not have autonomous driving without the ability to deliver a critical update to address a security or an improvement to the model. And certainly, there's a lot of pressure on enterprises across the world to keep up and not be hampered by slow-moving, static, or planned organizations, such as example of Ford, right? They're ideally situated for a global expansion and global delivery of vehicles. And on the right side, you have a Tesla that's really designed to rapidly deliver new innovation. And a key fundamental difference in their organization, it's very dynamic and policy-driven versus static and planned. And so IT itself must keep up and evolve and change as well in order for it to not become the bottleneck to the business. And that's why you're seeing this evolution from a development model from monolithic to, or waterfall to DevOps, as well as monolithic to a microservice base, as well as evolution to a cloud-based infrastructure. And certainly containers are a big part of that movement as well. From a security perspective, you know, it's typically been an afterthought. As I talk with organizations, it's typically with the operation and not with development or other parts of the organization. And so there's a real emphasis on how do you enable security from the get-go. It's certainly with the evolution of this architecture. What are the security implications, such as microservices? Right? This is becoming more of a distributed, and so the network is increasingly becoming more important. So the communication from service to service, how do you make sure that it's encrypted? How do you ensure that you're rotating the keys in an automated way? Also, the evolution to DevOps, right? Ensuring that you can rapidly release new capabilities is important to the business, such as that example for autonomous driving. And security cannot be viewed as a bottleneck or slow it down. And so it needs to really be integrated into the process. And then what about the implications when you move to a multi-cloud or a hybrid infrastructure? Do you have separate processes and separate tooling for each individual provider? And the evolution from a upfront cost to more of a consumption model. Think about if there's a security attack, that could potentially drive up my costs unexpectedly by consuming more resources. And there's the movement towards multi-tenancy, right? Every business lives side by side. How do you ensure that there's secure data practices in place? And so that's the movement to DevSecOps. DevSecOps is about integrating security into the culture of the organization, also automated processes to ensure that it's not the bottleneck, and in leveraging open source technologies. And so how do you manage DevSecOps at scale with containers? And that's where Kubernetes has really become the de facto standard currently with the automation of containers across any provider, whether it's physical, virtual, private, or public cloud. And Kubernetes can also be seen as a standardized platform from a security perspective. I can have the same tooling and the same processes across whether it's Amazon, Google, Azure, OpenStack, VMware, or my bare metal servers. And Kubernetes, by default, if you download it from upstream, it's not necessarily secure, right? You need to configure it properly so that you have the proper security. As you've seen in frontline news articles such as crypto mining software being installed in container images, or open dashboards to your Kubernetes infrastructure exposing your data and your infrastructure to the outside public world. And so when it comes to securing your environment, there's some best practices to adhere to. One is to take a layered security approach, right? Not one security knob will ensure security across the board, so you need to address security at many different layers, and we'll talk about those. Also, an architectural perspective, give the least privileges required for your services or your application. And then thirdly, reduce the attack surface. Do not install all into your container image, but just the bare essentials. And immutable. Make your container images immutable, not changing, right? Remove the configurations, remove the dynamic data from the actual image. And so containers themselves enable DevSecOps because they reduce the footprint that's in the container image, right? You're delivering your application with just the bare essential application dependencies and operating system dependencies. It's self-contained, so it has everything that it needs. It doesn't depend on the host operating system for libraries. It also allows you to have multiple versions side by side, and you're able to remove the configurations, and we'll show how in just a minute. And one of the key things of a container as a developer is I can build it once without having to worry about my target platform. Right? I can take that container image, install it on my laptop, my development environment, on a public, private cloud, or bare metal, or virtual infrastructure. And that is all made possible because of the Open Container Initiative that provides a standardization on the image format, also the runtime spec, as well as the distribution spec as well. Think of this similar to like a JE spec in the Java world. I have a standard jar format, and I have a standard runtime, but this is for any language. And Kubernetes delivers automation. If you haven't used Kubernetes, we'll show just some of the basics. One is you can define an application, such as 2 web servers and a single app server, and it's declarative. So I state the end state, and Kubernetes will take care of the provisioning of the compute, the network, and the storage for me. And so I've defined 2 replicas for my web server. The deployment controller in Kubernetes will go ahead and schedule an available resource across my cluster and deploy this web server and the application server. It'll pull the images and set up the networking and set up a service to front end each of those and load balance the traffic across, as well as set up a ingress so outside traffic can hit my web server. Second thing it does is it also performs a health check. So it continuously monitors my infrastructure and makes sure that it's receiving traffic. If it detects a failed pod, it'll actually go ahead and replace that automatically for me. And then the third thing from automation perspective is it auto scales, right? It detects the amount of traffic hitting my service, and it will scale up a resource based on the thresholds I've defined. Right? But what about security? So we'll talk about container image security. The basic flow in building containers is to define a build file, and that will create the container image. I can then share that via a registry, whether it's public or private, and then I can deploy that across my cluster, whether it's bare metal, physical, virtual, private cloud, and it can instantiate a container instance. Now, the container image itself is a transformation from a developer perspective. Instead of delivering a jar file, if I'm developing in Java, I'm now going to deliver a container image. And what's inside this container image? Well, it includes my compiled application, but also includes any of the language runtimes that I need to run that application, such as a JVM. And it includes the OS dependencies, right, outside of the Linux kernel. And that allows me to have everything I need to successfully run that application so I can have multiple versions side by side. But what about security? Do I now, as a developer, have increased responsibilities for these additional components? And the answer is no. It doesn't have to be that way. You can actually carry over probably your same process today, is that you have an admin owning the OS layer, and then you have your application team owning the middleware, and then the developers developing the actual code, right? And then you can build on top of those layers and produce a combined container image with all 3 layers, right? And that's what you would deliver to dev, test, and production. And then the configurations and the storage, that remains separate from the image, right? We want to treat it as immutable. So a converged software chain. Another best practice around containers is to treat them as immutable. And within Kubernetes, you can store your configuration data in what's called a config map. Config map is a key value pair that's stored in your etcd and the master server of Kubernetes. And so that allows you to store a configuration for an application or a config file, for instance. Right now, I can actually keep that separate and configure it at runtime. Also, if I have any data that I need to store from a persistence perspective, I could either remotely access a data services, maybe via JDBC, or I can have Kubernetes provision a persistent volume backed by some sort of network storage, NFS, block, Ceph, etc. And let's take a deeper look at a config map example. So if I have an application that's configured by an XML file, I could save that in my source code repository, version control that, and then I could define an application in Kubernetes to consist of my container image and then also associate it with a config map. And that config map would be defined as my XML file in my Git repository. Now, when I deploy the application in my cluster, it would take that image and create a container instance in my Kubernetes cluster. And within that container instance, depending on how I defined it, it would set the file as the environment variable. Or in this case, I would most likely have it create a file on the file system. So it would be mounted into the container instance. And Kubernetes will actually refresh and check if there are any updates, so I don't have to restart the instance as well. That's not the case for an environment variable. I'd actually have to restart it if I change the config map. Now, if it needed to be encrypted, I could also leverage a secret, and that allows you to store a password, for example, and make sure that it's encrypted at rest or as well as encrypted in transit to the container. Some best practices around build files. Here on the left side, you see a very simple hello world, but it also has some good formatting and good syntax in terms of how it was written. Right? It explicitly states where the container registry is with the fully qualified domain name. It also specifies a user. Right? The default for a container is root, and we certainly don't run as root, so you want to specify a user. Also, it doesn't use latest, so it specifies a specific version. Right? So latest isn't necessarily the same today as it is tomorrow, so you want to make sure you specify a version as well. And then also make sure that you're signing and validating those images before you instantiate them within Kubernetes, and you can do that. We'll talk later about emission controllers, which enable you to do that. Right? What about continuous builds? So here is a CI/CD pipeline in a typical Kubernetes environment. Kubernetes allows you to set up different namespaces. In this case, I have a dev, a UAT, and a production namespace, and so that provides network isolation between those environments. And here's the general flow: is my developers are checking in their code, operations is checking in, for example, the build files, and it goes to the build phase. And one of the best practices with containers and building them is to leverage a build image. A build image is just a container image with all the build tools necessary to compile your source code. And instead of having your target image be consisting of the build tools and your application, it just produces the output, which is your application and just the bare minimum, right? So you just leverage the build image during the build phase. And then the target image that it creates would be stored in that image registry, deployed to dev, test, and then production. So build once and then deploy anywhere. Now, one of the best practices from a security perspective is I want to make sure that these builds are reproducible, right? So let's dig a little deeper on what we did there. Is on the left side, I had my source code for my Java application, version 3.1. I checked it into Git. And in the middle there, I have a build image. That build image has the Java build environment, right? It has the language runtimes and the OS dependencies, and I versioned it version 101, right? So to build my source code of version 3.1, I'm going to use the 101 build environment. And that will produce a container image, version 3.1 of my application, which I'll go ahead and deploy and test, right? And so the benefits of this is that it's reproducible now. I have a immutable build environment image, and I can go back in time and recreate version 3.1 of my application by leveraging that build environment version 101. So very useful for debugging, reproducing as you move forward in time. Also, another best practice is cascading rebuilds. So once I have the container out in production, I may want to trigger a rebuild. And I can do that in as automated or semi-automated manner by monitoring the registry to see if any of the images, layers that I depend on get updated. Right? This allows independent folks such as the ops and the middleware team to update their layer, and I don't have to monitor and worry about that. I can actually just have an automated process that sees if the admin team updates the bare OS image, it will actually automatically trigger a rebuild process. Next, let's talk about container registry and scanning. So when you're pulling down images as a developer from public registries, you need to be aware, is that a trusted source that I'm pulling from, and what's inside that container image? And so from left to right, we have a C, Java, Node.js, Perl, PHP application, and it shows the dependencies that image is pulling in at build time. So in the second column, I have my Java app. It pulled in the JRE. And you can see the little triangle, it says 66. There's been 66 security notifications for the JRE. So I need to be sure when I'm pulling down something, is it safe to be using that image? And in the future, are there new issues that pop up? And so in order to address that, typically you'll set up a private registry so you have a trusted source within your organization. You also have an audit trail, and you can maintain the full life cycle and the lifetime of these images. So if I need to go back in 13 months, I can have that older version still in the registry. I'm not depending on a third party to keep that around. And in integrating security scan into your CI/CD pipeline, here's an example of a Jenkins build pipeline. Right, so I have build 1, 2, and 3, but I've added a phase in the middle here that after I build the container image, I conduct a security scan. Right, this allows me to address any issues that pop up after I initially maybe pulled down or created my first image. And you can use a variety of tools out in the marketplace. One is called OpenSCAP, which is an open source tool. It allows you to scan for container vulnerabilities, and it allows you to check to see if that image complies with a security policy. Right? So there's some out-of-the-box policies such as like PCI compliance, and you can select which rules you want to check for, and you can customize them as well. And if there's a violation of any of the rules, it will create an Ansible script to remediate the particular issue in your image. Now the tool works against bare metal, virtual, and containers as well, and multi-distro. And from a vulnerability perspective, it will identify those RPMs that need to be updated, and then you could remediate that by updating the image with the latest versions that address the security issue. Now what about CI/CD, right? So one of the differences as you move to a containerized DevSecOps practice is that typically today, if there's a security issue, maybe you go in and you SSH into that box and you apply a single update to address that security issue in production, right? It's quick and simple. I didn't have to interact with the developers, and I didn't have to go through that long process of pushing it through the pipeline because it's very manual today. But as you move to an automated CI/CD pipeline, you can deploy in minutes. And so every update, every security issue should be addressed in development and then pushed through the entire CI/CD pipeline, right? So I can build that container once in development and then push it to QA, have the security tests, and then staging, and then to production. And so how do I deploy at scale in an automated way? I don't want to write scripts. I don't want to do it manually. It's much more difficult with containers now that I have not one bare metal server or 10 VMs, but maybe I have 100 or thousands containers I need to update. And so as a developer, I want to be able to test out that change, that security fix. And so Kubernetes enables automated A/B testing with canary deployments. And that's really key, is to enable development to try out and experiment. And if things are working, then to go forward. But if they're not, to be able to stop and put a pause on that. And when it comes to a security update, I want to do exactly that. I want to make sure that it doesn't break things. And so here's an example. On my left, I have my current version of my mobile application backed in with a recommendation engine. And in version B on the right, I updated that recommendation engine with some new logic. I want to see, did that improve the recommendations? Are people going to click through more often? And it included a security update as well. And so in Kubernetes, what I can do is I can deploy my pods and I can put labels on them. In this case, app equals demo, version equals A. And then I can create a service in front of those pods with a selector of app equals demo and version A. And so all the traffic will be routed over to the left side. And I'm currently getting a 25% conversion rate from that recommendation engine. But as I had a security issue and development, I want to see it does that new version address that issue. And so I can go ahead and deploy version B on the right side, and I can perform a health check on it. And once it passes the health check, I updated the service, so the selector is app equals demo, so it'll go to version A or B. And because I only have one pod of this version, 25% of the traffic went to the right side. And I see that it had a positive impact on my conversion rate. The security solution did not cause any negative implications to my business. Right? And so then I'm going to go all in, and I just update the selector to version equals B, and the traffic will eventually die off on the left side and move over to the right side 100%. Right, so canary deployments. Now, what about external services, though? Typically, when I go to a container environment, I'll move my web and app to the cluster, but the database typically is pretty sticky to where it is, and it may live outside of the cluster. Right? And if I have a security issue and I need to move from one database to another, how do I quickly do that when I don't actually have full control over it? And so Kubernetes allows you to interact with external services. So on the left side, I have, for example, a Mongo database. This is my development instance, the red one, and then my production is the blue, right? So I want to move from one version to another quickly without bringing down my application. And the way I can do this is I can deploy my web app into Kubernetes on the left, and then these external databases are out in the public cloud. They have some IP addresses. And what I can do is in Kubernetes is define a service that is of cluster IP and name it Mongo for my Mongo database, specify the ports, and associate an endpoint to it. So this is just a network IP that these external services have. And this allows me within the application to connect to those external services just using a static string of MongoDB : //Mongo, right? I don't have to hard code the IP address. And if I need to switch from the red to the blue to address an issue, I can simply change the IP address of the endpoint, right? I don't have to restart my application. I don't have to restart the pod. I just update the endpoint. And so I can quickly move my connection from the red to the blue data service. So very useful in moving quickly in your pipeline. Now, if it's a dynamic URI, I could also do that by specifying the service as an external name instead of a cluster IP as well. So some flexibility depending on what your service provider gives you. Also, what about databases? So I have this new version of software that addresses that security issue, but it also requires a new version of the database schema to go along with it. And I'm hosting that database within my Kubernetes cluster. So how do I move quickly? Right? I have version 1 of my app in the database schema in production. I have another version in test and in development, and I want to move those from left to right. Well, what I can do is use a schema version control software such as Flyaway, which is an open source solution, allows you to define the schema update and version control the schema. And so what does that look like? How do I do that in Kubernetes? Well, on the left side, I have that migration script to take me from version 1 to version 2 of the schema. And then I have a container build file, which will build a flyway image, including that version 2 update script. And then on the right side, that's the resulting output, is I have a container image called flyway mydb version 2 for version 2 of the schema, and it includes everything necessary to make that happen. And so within Kubernetes, I can go ahead and deploy my PostgreSQL database, and you can do that because Kubernetes can provision persistent storage. So I have created a persistent volume, and that instance has a persistent volume claim. I currently have the version 1 of the schema. I want to upgrade it to version 2. So I create a job in Kubernetes to launch the flyway image, and it creates an instance within my cluster. It's scheduled on my available nodes, and I specified the database password as a secret in my definition of that deployment. And then once it started, the flyway went ahead and executed the migration script, and it connected to the Postgres database via a JDBC connection, applied the schema version update, and now I have version 2 of my schema. Right? So if I'm doing an upgrade of the application of the database, I would typically, you would upgrade the database first, and then I would then go ahead and deploy version 2 of the application. Right? Very helpful also if you're doing blue-green deployments. So you can live with 2 versions side by side. Right? So an important part of this whole process with DevSecOps is to have a feedback loop. So here's some monitoring considerations. You're used to monitoring at the host level, but as you move to containers, you need to be monitoring the container level as well. So you can use the kubelet CAdvisor, and then also you want to monitor the control plane for Kubernetes. And then as you move to microservices, you need some tooling to do distributed tracing. So things like Jaeger allow you to do distributed tracing. It's an open source solution from Uber, and then Istio is based on the Envoy proxy from Lyft. Those are some great tools to help you with logging and tracing of your microservices. And then Prometheus gathers a variety of metrics, and Grafana displays those metrics in a visual dashboard for you. So here's some tools to consider from a monitoring perspective and to give you that feedback loop. From an architecture perspective, if you take a look at Kubernetes, here's a basic control plane. On the left, you have the API, UI, and the CLI interfacing with the API server, which is really the main controller. And then you have the scheduler, and then the actual controller, which does replication, for instance. And then you have your nodes in the cluster, and then etcd is storing, for example, your cluster configuration, your config maps and secrets as well. And then within the node, you have your kubelet and your container runtime, which is not provided within Kubernetes, but we provide a interface to any third-party container runtime that is compliant with the CRI spec. And from a security perspective, you want to make sure that you encrypt your traffic and enable that within Kubernetes, so you can encrypt from the user to the API, to the kubelet, and to the pods. And so that's an option within Kubernetes. And then it's also important to understand from an architecture perspective, Kubernetes doesn't provide everything you need to actually deploy a production instance. You may need a Linux operating system, you need the container runtime, you need a networking SDN, DNS, storage, if you want shared storage and persistence, and you need a management dashboard potentially for monitoring, logging, and a registry to provide those images as well. All right, what about networking security? Right, so the default networking model for Kubernetes is really a flat. All the pods can talk to each other within the namespace, right? And then your traditional network is a 3-tier model. You typically have a DMZ, you have your application tier, and your database tier. How do you apply Kubernetes to your existing network model? Well, here are some of the best practices from left to right. Typically, on the left is when you have one cluster per zone, right? I'm not showing the DMZ, but I'm showing the app and the database tier. And so the app tier would have its own Kubernetes cluster, and the database tier would have its own Kubernetes cluster. And those applications that live in the app would deploy to that cluster and use the ingress egress for your network zone B. And this middle is one cluster per multiple zones. So you have a single Kubernetes cluster, but I've used labels to label my pods A and B and to have them use the ingress and egress for zone A. Right? And then likewise, my C and D applications, which are my database, would be labeled to use the ingress egress of my database zone. And then a third choice that we see folks doing is they want some separation of their database and their applications not residing on the same node in the cluster of Kubernetes, but having a single Kubernetes cluster. And so here you could label the nodes with a label, and the scheduler, when you schedule, for instance, your database, could select just the database nodes, and so only C and D apps would run on the blue nodes, and then they would use the ingress and egress of your zone, your database zone. All right, so this is a little less efficient in terms of resources, but some folks feel a little bit more comfortable not having database and apps live side by side, for instance. And network namespaces is built in to the Linux operating system, and it provides that logical separation so that you can have logical environments, dev, test, production on the same physical infrastructure in Kubernetes. So you can have a single cluster for all three environments. You don't have to have a separate environment or a separate cluster per environment. And also that enables multi-tenancy, so it can have multiple applications live side by side with complete network isolation. Also, as I deploy my application, I may want to define a network policy that's included. If your SDN supports network policy, you could actually, by default, as I mentioned, pods, the ingress and egress is open by default within the namespace. So you want to make sure a good practice is actually to disallow all traffic as a default policy, and then just to whitelist what is allowed in your environment, and you can do that through a network policy. So that's layer 3 and layer 4 of your network with the Kubernetes network policy. If you want to apply policy to pods, Kubernetes has a way to apply that. But first, it's important to understand kind of the different security capabilities that are built into Linux. They really provide security for the containers at the node level. You have C groups, which provides quality of service, so you don't exceed your network memory CPU utilization or usage. You have namespaces, which I mentioned, user and network. SC Linux provides mandatory access controls, so every process has to explicitly be stated what it can have access to. So even if you're a root process, you can't necessarily access everything on the file system, for example. Setcomp filters. That allows you to limit what Linux system calls you have access to. So there's a couple hundred different system calls, and you want to be able to filter that out so that not every process needs access to all system calls. And so if you limit that, it's kind of a best practice so that you don't get exposed to potential vulnerabilities. And then Linux capabilities, right? So a root level user has access to a lot of different capabilities on the Linux system. You could limit that by defining which capabilities they have access. And then a best practice is always to mount your file systems as read-only if possible. Right, so those are some of the security capabilities within Linux, and then Kubernetes allows you to define a policy, right? So on the left side is a really open policy, and then on the right side is a restrictive policy, so we can define SE Linux restrictions, for example, and you can apply this at creation time to your pods. And the way it does that in Kubernetes is via the API server. And so on the left side, you have your user or your pod requesting the creation of a pod, for example, and so it'll authenticate. And if you have role-based access control set up in Kubernetes, you could define what that user can do. For example, let's say it has the ability to create a pod. I could then after authorization, Kubernetes has what's called an emission controller. And the emission controller can be defined, for example, to mutate or validate the particular object that's going to be created. So let's say you're creating a pod, I could transform the policy of that pod before it's instantiated. Or I could validate that that pod actually adheres to a certain policy. And so this is a great way to apply the pod security policy. So I could enable, for example, SE Linux. I could enable no root users to be running the pods as well. And so once I do that and I apply that mission controller, I could then launch the pod in my cluster. Right? So some best practices at the node level. Don't run your containers as root. Limit the Linux capabilities. Don't SSH into your boxes. Also, make sure you're using namespaces. Define resource quotas for your microservice that you're going to deploy. Enable logging, so you have centralized logging. Have some sort of third-party logging tool integrated into your Kubernetes cluster. Make sure you're applying the security errata to the host level as well as the container image. And you can use seccomp filters, for example, to limit system calls. And make sure, run production on privileged containers as read-only. So some container runtimes allow you to run as read-only. Right, so what's next? Kubernetes is a platform which is being built upon. Here's some active projects that are being built upon that. One is the ability to manage virtual machines. Two is operators to automate the operations of your services that you deploy. Knative is around serverless on top of Kubernetes. And then Istio is service-to-service traffic control and security with mutual TLS. And then Tecton is a new project to help define CI/CD pipelines, which front end, for example, maybe your Bamboo or Jenkins a CI server, right? Okay, and so sorry we're out of time, but as you make this transformation, DevSecOps, here are some metrics you may want to follow. One is track your compliance score. Two is your deployment frequency. Three is the lead time, deployment failure rate, MTR, and service availability. So thank you very much for attending. My name is Chris Vantine. Here's my email and Twitter. Feel free to reach out, or if you'd like to have a deeper dive into this discussion, we can certainly set that up as well for you. Thank you.